This Harry Potter, a hilarious new Harry Potter chapter, except it's written by AI and Potter's perfect Harry Potter, and it goes hilariously wrong.
So of course, I've clicked on every single one of these articles. And not just for this video, I just thought the articles were funny. But when I read this excerpt of Harry Potter written by an AI, I think, that's not word salad, that's semi-coherent. How did an AI generate that? It turns out the answer is it's not generated by an AI, at least not entirely. So what does it mean to have an AI write a chapter of Harry Potter? I mean, obviously, I know it means that on some level a human did not write these words, that a machine did. But there's a lot of meta questions here. What makes this a chapter of Harry Potter? What is Harry Potter? Did someone just create a script that generates random stories based on characters and settings, Mad Lib style? Does that make it Harry Potter? I mean, does that make it AI? Harry Potter and the Portrait of What Looked to Be a Large Pile of Ash was written using a tool called VoiceBox, which was in turn created by Botnik Studios, an entertainment company created by former editor for The Clickhole and The New Yorker Jamie Brew. Before getting too far into this video, I want to shout out Botnik and Jamie Brew for being just all around fantastic. They offer free use of VoiceBox on botnik.org, where in addition to Harry Potter, you can generate things like Thanksgiving recipes, songs in the style of Taylor Swift or Kanye West or a ton of other artists, or even BuzzFeed quizzes, which would certainly be better than the content that BuzzFeed actually makes. Shout out to this especially shitty BuzzFeed article where all the pictures are just replaced by the text, "This image does not exist." Also, shout out Seption to this ad for incontinence underwear. Anyways, I used VoiceBox to generate a sentence of Harry Potter, and this is what I got. Hermione said in their absence saw Mr. said Dumbledore, simply they did seem a very supercilious. He thought about what he saw tear inside all pretense the other Weasleys lying. That is the word salad I expected. So what's going on here? Why is my VoiceBox excerpt having a stroke, while theirs is a viral comedy sensation? Well, AI is a really complex and honestly incredibly misunderstood idea in pop culture. AI isn't alive, it isn't thinking. Most AI in reality are just a specific type of computer algorithm known as a machine learning model. These are different frameworks that can take a massive amount of information and digest it a billion times faster than a human. And since they can process so much data, they can see and emulate advanced patterns and make very accurate, sometimes scarily accurate, predictions and decisions about this data. A computer can analyze and draw conclusions about data sets so massive that it takes just a few hours or days to analyze what might take a human hundreds of years to do. Obviously, an impossible task, unless you've got a philosopher's stone. So obviously, whatever AI model is behind this Harry Potter excerpt, it's not alive, and it doesn't understand anything, let alone what makes a Harry Potter book tick. But what it can do is process the existing Harry Potter books, establish some patterns in the writing, and then use those patterns to predict what new sentences or chapters might look like. Enter Markov Chains. Markov chains were invented by Russian mathematician Andrei Markov and are used in everything from weather prediction to modeling DNA evolution. Heck, Google even uses Markov chains for part of their search algorithm. And yes, they are also used to generate hilarious text in the style of an author or series. The way it works is actually remarkably simple. To explain, let's think about how an author writes a book, but from a computer science perspective. To start, we have to define some basic form of the data you'll want to generate. We call this a token. In the case of writing, one token is one word, or punctuation mark, because that's the most basic unit of a book's data. Okay, technically that's not true. We can break down words into letters and letters into individual pen strokes, but an AI that generates random pen strokes is meaningless, at least for this purpose. We want a story, not abstract art. And unless you're in kindergarten, you don't write by thinking, okay, I'm gonna write the letter C, then the letter A, then the letter T, because that's not how a normal human being writes. They just think about the words. They think, I'm going to write the word cat. So we want our AI to work in words, not letters or pen strokes. Alright, so we've got our token. Next, we need to train our AI on some data. We'll call this data the input. We want our AI to write in the style of Harry Potter, and we need data to train the model. So obviously, we'll use the Quran. Nah, I'm just messing with you. We'll need the raw text of all the Harry Potter books as the input. Great, that was easy. We've got our token, we've got our input. All we need to do is tokenize the input. You can probably guess this, but just to be explicit, tokenizing means breaking down the input into tokens, breaking down the book into words. So we've talked about tokens, input, tokenizing. What does any of this have to do with Marky Mark and his chains? Well, Markov Chains build a network of all the tokens and assign probabilities, likelihoods, of one word following another. Think about the following example. Harry, Ron, and Hermione all talk, obviously, throughout the whole book. So there's going to be some probability, some chance that after the word said, we might see any of the words Harry, Ron, or Hermione. But depending on how much each of these characters talk throughout all the books, will change the probability that their name will come after the word said. After looking through all the books, Harry's name might have a 40% chance, Hermione's a 35% chance, and Ron's only a 25% chance. Of course, there's many more characters than just these three. So in reality, there would be many edges here, going to all the characters whose names follow the word said. Of course, there would also be probabilities relating Harry, Ron, and Hermione to each other, representing how often their names are seen back to back in the book, like if someone was listing all their names out. And yet more probabilities for the chance of the word said coming after any of these characters, producing the phrase Harry said instead of said Harry. Now imagine repeating this process for all 77,957 unique words in the Harry Potter series. This is why we need AI to process it. That's about it. The AI can just use these probabilities to generate some text. It picks a random starting word, and then it uses these probabilities to generate the next word. And remember, punctuation marks can also be tokens, so we can just end the sentence when we run into a period, a question mark, or an exclamation mark. So this all sounds well and good, but there's one tiny caveat to Markov chains that made me want to make this video in the first place. You can only use Markov chains to model scenarios that abide by what's known as the Markov property. Man, this guy was conceited for being a communist. What is the Markov property? Well, it's again very simple. It just means that the probabilities of future words can't be changed by past words. The entire system has to be memoryless, otherwise this model doesn't work, since you'd no longer know the probability of future words. There are other machine learning models that can mimic memory, but not Markov chains. This is why those AI-generated texts always seem so non sequitur. They literally can't keep a coherent context if they tried, because they don't track the words that were used in any previous sentences, or even earlier in that same sentence. And this is what initially made me skeptical of the generated Harry Potter chapter. See, if you read this AI-generated chapter, it is remarkably good at keeping context for being generated by a Markov chain. Luckily, the author Jamie is fantastic and has actually shared how he created VoiceBox, which is actually how I learned that VoiceBox doesn't generate text by itself. The code actually builds a Markov chain model and then gets its help building sentences word by word by offering a human user a choice of 10 words to use next. It's actually a human picking the words that come next. It's just the only options the human can choose from are the words decided on by the AI. It's not quite AI, but it's sort of AI. Now, again, this is not a hit piece. I don't think it's Jamie Brew or Botnik's fault that news websites have been reporting like this. And they're clearly not trying to deceive anyone. Botnik's website even lets you try this process of choosing words from a list of AI-generated recommendations. What bothers me is the way that the news reports it, and more generally, the way that AI is represented in pop culture by media. But honestly, to be fair, it's hard to tell if I'm just being cynical. Let me know your thoughts. Now, I felt like I couldn't end the video without coding something, so I wrote a simple Markov chain generator and I ran all 10 seasons of my favorite show, Adventure Time, through it to see what my version of a Markov chain generator could come up with. And I let the bot choose the words itself, without my help. Although I did organize the lines a bit to try and give it some semblance of meaning, so I would say it's not generated by an AI. At least, not entirely.
Bimo eats a bit of hair.
Oh, Lorraine is dinosaur bones.
I've been the bait for the fun tray.
What's going on? We just wanna go home.
No, it spews evil spores across the street.
Ice King flies out of his mouth.
Sorry, sweetie.
The scene switches to him in bed, moaning softly in his sleep, while his eyes move frantically behind closed eyelids.
Careful, dude.
Finn pokes him with a stick and then throws it at the wall, then swivels it back to the future fern tree.
That's not the plan, Toids.
Finn.
Finn and Jake view another tape, on which the Ice King is laughing and carries Jake to the window.
Oh, I'm hanging with Finn?
Nope, no bro.
I think he looks like a cage-free ball of lint.
And that's how Markov chain generation works.